All right, everybody, welcome back. So now we're going to be focusing on the math, and I believe the math is on page 452 and 453. All right, so we left off here with the process of the X-ray striking the intensifier tube. So we're going to go ahead now and work the math into this here. All right, so the first math here, it says magnification gain. So there's three math problems that we're going to do. We're going to be doing what's called magnification gain, minification gain, and total brightness gain. I don't know why I close my eyes. It's like I could see it sometimes in my head. I don't know why I do that. So the first math that we're going to do is magnification gain. So let's see. We got black right there. So magnification gain is going to be your input phosphor screen. And this is on page number 452. Okay. All right. So you got input phosphor screen. I might use a different wording, by the way, you guys. So just bear with me. I'm saying the same exact thing, though. You have your input phosphor screen divided by your input phosphor screen being used. Input phosphor screen being used. So believe it or not, being used, this input phosphorus screen can come in three different sizes. It's called a multi-field system. So this whole thing right here, right, is your input phosphorus screen. You can have it in, let's say, 23 centimeters. You can have it, I'm going to change it up to, I'll say, orange. You can have it in 17 centimeters. All right, so it's only going to use 17 centimeters instead of the whole thing, right? And then you can have it in, let's say, 23 centimeters. I'll use, I don't know, brown. So here we have brown. It could be 14 centimeters. So you can have the ability to change up the surface area that you want to use. And the reason why we were able to do that is when you have a smaller input screen phosphor size selected, you're going to get magnification. And sometimes the doctors will say, hey, can you mag it? And that means magnify it. All right, can you make it bigger? Zoom in on it. And when you do that, sometimes we have mag 1, mag 2, and then we have normal mode. So normal mode would be using the whole 23 centimeters. If they say, hey, can you mag it? And you got mag 1, you press it, it'll jump down to, let's say, 17 centimeters. And I'm going to explain exactly what's happening. But I want to tell you what's going on first, and I'll work it out for you. So then, let's say he said, okay, or the doctor says, he or she says, you know what, make it smaller, make it bigger, right? You can change the surface area, all right? So let's say they say, make it bigger. I want it the biggest you got. So then you can go down to 14 centimeters. Some systems just have mag 1, mag 2, and what it's doing is it's changing the input phosphor square selection, the input phosphor surface selection. So I'm going to explain exactly what's happening here, but I'm going to write out the math formulas first. So for magnification gain, write this out 10 times. I'm telling you guys. All right, you want to remember this formula? Write it out 10 times. They say it takes 6 times to be recorded into our subconscious mind. Write it out 10 times, right? We're a little hard-headed sometimes, right? I know I am. It takes me 10, 11 times, sometimes 12. I don't know. So write it out 10 times, and I'm telling you guys, you'll remember it, okay? So magnification gain is input phosphor screen divided by the input phosphor screen being used. Then we have minification gain. All right, so minification gain. All right, it's on page, 453. Minification gain is your input square, your input phosphor screen squared divided by your output phosphor screen squared. So input over output squared. All right, so there's going to be 3 math problems, okay? 3. Magnification gain was the first one. I'll put a 1 right here. Number 2 is minification gain. And then the last one, the third one, is called total brightness gain. total brightness gain. TBG. And what that is, it's called flux. Flux is just energy that travels over distance. So flux times minification gain. They always have to give you these numbers, by the way. You just have to know what to do with them, okay? So these are your formulas. And again, they're found on page 452 and 453. But I'm going to explain. I'm going to do the math problem with you. But I'm going to explain to you exactly what's happening, all right? So it's best to know, all right? So magnification gain, minification gain, then total brightness gain, all right? So now, I'll leave that up there for a second. Let you guys take a look. This is why it amazes me when people say, all you do is press a button. And they have no idea, you guys, about the stuff that we have to know. They really don't. People are really ignorant. They're like, what? You just press a button. They have no idea, you guys, on the stuff that we have to know. That's why I give every healthcare worker, is admirable, I think. But I don't know. Maybe I'm biased because I'm a radiographer, but man, I give a lot of props to and respect to radiographers. All right, so let's go ahead and do the math now. All right, so I'll go ahead and I'll use the numbers here. I'll use the numbers here, but there's also a handout and a packet that you guys should have or get. I don't know if it's in Canvas. If not, I'll check with Mr. Gomez. But where you're going to go ahead and write out the formula. The formula is given to you, but then you have to create your own math problem. And I think that works the best because I got that idea from another student. So, Mr. Aaron, when I created my own math problems, I just remembered it more. And I'm like, you're right, because you're taking ownership of it. You're doing it yourself versus it being given to you. And there's actually more retainment that way. So let's go ahead and do the math. Magnification gain. So it says here on the first one, it says, what is the magnification gain for an image viewed with an image intensifier tube with an input phosphorus screen of 9 inches, which is 23 centimeters, that is using a 5-inch or a 13-inch diameter area of magnification? You know what I'm going to do? I'm going to go ahead and show you. I'm going to show you what happens when you use the full 23 centimeters first. And then I'm going to do 17 and then 14 centimeters. I'm going to deviate from this book, okay? Sorry, you guys, but I think the way I'm explaining this, you're going to understand a little bit better. Watch. I'm not saying my way is always better, but you're going to understand it better. All right, so here's your intensifier tube, right? I'm going to draw this layer here. Let's say you're going to do the whole 23 centimeters. So magnification gain, we said, was input phosphorus screen divided by the input phosphorus screen being used, correct? So input, I'm just going to put input screen, okay? You guys know it's phosphorus screen. Input screen over input screen being used. So if it's 23, it'll be 23 because that's the whole input screen. And what's being used? We're using the entire thing, right? So it'd be 23 divided by 23 equals 1. Well, if it's 1, there's no magnification. All right? So this is why I'm saying I'm going to deviate from what the book has here, the numbers, and I'm going to use my own numbers, but you're going to understand it a little bit better if you're following with me. All right. So now, let's say the doctor says, say Dino. All right, Dino's over there in the corner. So Dino, he's in surgery, right? Doctor says, you know what, Dino? Can you mag it? I want to see it bigger. You're like, I got you, doc. And you hit mag 1. What happens is it's going to go from that 23 centimeter and it's going to go to using a 17 centimeter screen, okay? So let's use, what color did we use on that other one? I want to try to use the same color, like a gold color, right? Okay. So we got a gold color. Let's go back to that gold color here. All right. So now you're going to use 17 centimeter. All right. So let's take a look here. Go back to black. So now this was our first exposure. Let's say our second exposure. The whole entire input screen is how big? 23 centimeters. Input screen divided by input screen being used. Now for the second one, let's say we're going to go ahead and say, Dino, go ahead and magnify it, make it bigger. and Dino hits mag 1, right? Or he can select the next size that's smaller. In this case, it's 17 centimeters. So now we got here 23 divided by 17, right? All right, 23 divided by 17. Mr. Gomez spoils me, you guys. This guy brings me coffee, brings me a sandwich. Man, that guy spoiled me. Today he brought me a scone, and I said I was only going to eat a little piece. It was a cranberry and orange scone from Porto's. Have you guys ever had that? Oh, my God. I keep saying I'm going to watch what I'm eating, and I don't. I just watch it go in my mouth. So, but anyways, I'm still full from that scone and that cup of coffee. I don't know what it is, but, man, I want another scone, though. I'm not going to lie. All right, so going back to this, let's go back to show you how I got this 23 divided by 17. We got 1.35. You guys see that? So 1.35. So that means that this image that you hit Dino, right? Dino, you hit mag 1. Now it's going to make it bigger by how much? 0.35, which is 35% bigger. It's 35% bigger. Do you see that? All right. So now let's pick a third exposure. All right. So we got 1, 2, and 3. All right. So now, what did we use for that other exposure? That was 14. We used brown, right? So we'll go back to brown. We'll go to brown here. All right. So now we got here. Go back to black. You're using 14 centimeters. That's brown. I don't know why I changed the color right now, right? But the input phosphorus screen is what size? 23 centimeters. It's staying the same. Now, we're using how big? 14 centimeters. So if you're to take 23, input screen divided by input screen being used, you take 23 divided by 14. 1.64. 1.64. So that means it's 64% bigger. So this is why it's magnifying it, right? But I want to show you what's happening. So what I'm going to do is I'm going to make this smaller. I'm still going to go ahead and say 1.35 or 35% bigger. But I want to show you guys. Do you guys remember electrons are coming off this device, right? So when they come off, your focal point is closer to the output phosphor here. All right. So your focal point is closer to the output phosphor. It's going to bang off the anode right here, and it's going to minimize, right? So watch what happens when you use a smaller input phosphor size. Let's say we go back to gold. The input phosphor surface is smaller. So that means the electrons are going to converge a lot faster. So do you see how the focal point is further away from the output phosphor? That's what creates magnification. So now we're going to have this. And if you chose a smaller input phosphor, the brown one, let's say the 14 centimeters, look here, you guys. Do you see how the input phosphor size, when you get smaller, now the focal point is further away. And that's going to create a bigger field. You're going to get more magnification. So I'm going to write that on the board here. When the focal point is further away from the output phosphor, from the output phosphor, it's going to result in magnification. There's a couple things happening, but first I'm going to just write this down right now. All right. So the focal point, when it's further away, it creates magnification. All right. So I'm going to go back to this. I'm going to repeat it, but I'm going to add something else to it. Okay. So, but do you see here, when you have a smaller input phosphor selection, you're going to get a bigger image. And it goes back to the focal point being further away. I know my lines aren't completely symmetrical, but I'm hoping that you guys get the idea. So this was magnification gain. Okay, so magnification gain. Now, let's do minification gain. And we're going to use these same numbers. Okay? So, we're going to use 23, 17, and 14 as our input phosphorus screen. So, do you remember for your minification gain, was input phosphorus screen squared over output phosphorus screen squared, correct? And I'm telling you guys, write these things out 10 times and you'll remember them. I'm telling you guys. And if you can't remember after 10 times, that means you hit your head or drank too much over the weekend or did something. All right? Because, again, write it out 10 more times. All right? So you're going to hear me say that. You can't remember it? Write it out 10 times. Mr. Adam, I wrote it 10 times and still remember. Write it another 10 times. You're going to remember it. Have you ever got in trouble like me as a kid? Standards, right? So I don't know. They probably don't do that now. They probably think it's abuse, but they had us doing it back in the days. I think it kind of worked. So input screen squared over output screen squared. Now, ready? Let's use the first one. We're going to use 23, okay? So I'm going to go on this side here. I think I'm still in the field. So we got input screen, right? It's 23 centimeters squared. And we have output screen. Now, do you remember how big the output screen was, you guys? It was 1 inch or 2.54 centimeters, correct? So I'm going to use 2.54 squared because it's always about 1 inch in diameter. So let's do 23 times 23. 23 times 23. That's 529, all right? So equals 529. And if we do 2.54 times 2.54, it should be like what, 6 point something? 6.45. Okay, so 6.45. So now we got to go ahead and divide, right? So we go back to 529 divided by 6.45. We end up with 82. All right, 82. So I'm going to put here, you guys, number 1 is 82 for minification gain. I put min gain. All right. Now, let's go to the second one. Number 2. Let's say we're using 17 centimeters as the input phosphorus screen, correct? So that means we're going to have 17 squared over 2.54 squared. Ready? So 17 times 17 is going to be 289. So equals 289. Divided by 2.54 times 2.54. Oh, wait, we just did that one, right? And what was it? It's written over here, 6.45, right? 6.45. So now we got to divide 289 by 6.45, right? 289 divided by 6.45, and that's 44. Okay? So it equals 44 for min gain. So if these were electrons, guess what? You're getting fewer electrons, right? With the larger surface area, you had 82 minification gain. So you got more electrons compared to this 44. That's less. So believe it or not, these electrons will become brightness. So there's less brightness here with this lower number minification gain. So let's do the third one now. Let's do the third one. We got a 14 centimeter that we're using. So it'll be 14 centimeters squared over 2.54 squared, right? So now let's do 14 times 14. 14 times 14. What do you guys got? 14 times 14. If you're waiting for me to give you the number, shame on you. You should be doing it with me, right? So, all right, 196, right? one of my students, because I've done some videos, you guys. One of my students, Mr. M, oh, you have this thing about making me feel guilty during a video, and I know that you can't even watch me or see me, but you just do that. Like, oh, all right, good. All right, so 2.54 times 2.54. Wait, again, we don't have to do this, right? Because we know it's 6.45, right? So 6.45. Now, 196 divided by 6.45. What you guys get? What you guys get? I'm going to write mine down, and you tell me if you got what I got. All right, I got 30. Okay, so some of you guys have asked, Mr. Ram, do I have to round? Just leave it. All right, I know it's 30.38, but that's fine. Just leave it at 30. All right, so what do we notice? What do we notice? The focal point, as it gets further away, you're going to have less electrons reaching the output phosphor. So your minification gain goes down. Well, guess what? We just said when the focal point is further away from the output phosphor, we get magnification, correct? But we also have less minification. So less minification means less electrons, I'm going to put E's, reach the output phosphor. Less electrons reach the output phosphor, so you know what that means is there's less brightness. And because they're further away, the voltage has to increase and the quantity has to increase. So the MA has to increase, and when that does, it increases the patient dose. So when you have less minification, less output phosphor, less electrons reach output phosphor, you have less brightness. So all of these things are happening. You have less brightness. And when you have less brightness, we need more mass, more MA. All right, more MA or more time. And that's going to lead to more dose. So magnification is actually good for spatial resolution, believe it or not. In X-ray, we learned that it was bad, but in fluoro, magnification actually increases spatial resolution. So I'll write that on the board in just a few minutes. But I want to finish the math first, and then we'll go back to the fluoroscopic procedures. Fluoroscopy, you're going to find about 4 videos for this week, okay? So I'm trying to break it up. Now, we got 2 math problems so far. We got magnification gain, right? Magnification gain. And then we got minification gain. So what's the third one? What's the third one that we have to do? My shirt's sticking to me. What's the third one that we have to do? It's going to be minification gain again? No. Is it magnification gain again? No. It's going to be total brightness gain. So total brightness gain is how much light is coming out at the output phosphor. Okay, so total brightness gain, we're talking about the amount of light that's coming out. All right, so for total brightness gain, it's going to be flux times minification. Flux times minification. That was a nice bike. All right, so my uncle passed away a couple years ago. My uncle left my cousin his bike, his Harley Davidson, and my cousin said he would never sell it, but now he's selling it. But now he wants this ridiculous amount of money for it. But still, maybe we should get a collection going for Mr. M and help him get a bike, right? What do you guys say? All right, just kidding. All right, no, I'm going to put a little jar on the table right here for us. All right, so I'm just kidding. I'm just kidding. Okay, so we're going to go back to this. Flux gain times minification gain. All right, so they're always going to give you the flux, always. So here, you guys, this what if is if the total brightness gain for, what is the total brightness gain? I'm looking on page 453, right? For intensification 2 with a minification gain of 36 and a flux gain of 60. So let's use 60, but we're going to use these numbers, okay? So let's say the flux is 60. They always have to give you a flux. They'll give you the number. You just have to plug it in now. Ready? So I'm going to go ahead and do 1 2, and 3, because we're going to use the minification gain number 1 of 82. We're going to use the minification gain of, where we at, 44, and we're going to use the minification gain of 30, okay? But we're going to use the flux of 60. Ready? So 60 times minification gain of 82. All right? That's the first problem. The second one, we're still going to use 60. We're going to use it as a constant number. We got 60 times, we got 44, right? 44. And then we got number 3. We got here 60, the constant flux, and we're going to do 30. All right? So I want you guys that are watching this video to go ahead and multiply 60 times 82, put your answer, 60 times 44, put your answer, and then 60 times 30, and then put your answer. All right? And we're going to find out here, you guys, which one's going to have the most brightness. Okay? The most brightness. All right? So again, go ahead and write that out. 60 times 82, put your answer. 60 times 44, put your answer. 60 times 30, put your answer. We're just using that number 60 because it was in the textbook. A flux can be anything, okay? It can be 1, it can be 20, it can be 50. All right? I'm going to go ahead and I'm going to do the math too. Give you guys a chance to do it. Okay. I'm going to put over here TBG. You down with TBG? All right. So TBG, total brightness gain. All right. Now, what do you guys notice? Which one has the most brightness? The higher numerical value of numbers, right? It's going to be the first one using 23 centimeters, right? So remember what I put down. I put the focal point we use. When the focal point is farther from the output phosphor, you get magnification, right? So when you use a larger surface area, your focal point is closer to the output phosphor, right? But when you use a smaller input phosphor, you're going to get more magnification. You're going to get less minification. And we said less electrons reach the output phosphor, but you're going to get less brightness, right? And the system is going to have to use more MA and time, and that's going to result in more dose because you have less brightness gain. So when you use a larger input phosphor screen, you're going to have more brightness. It's going to be less dose to the patient. I'll write that on the board here, and just after I'm done doing this, I'll write some things on the board for us to understand about fluoro. But I want to draw out the math for you guys. And I'm hoping by explaining the math this way, that it makes more sense as you read it in the textbook and you discuss it in class on Tuesday. All right, and Wednesday. So again, do the reading, watch these videos, watch the presentation in Canvas as well. And then, I know you guys will be working on the review questions and doing your homework as a class. But again, you got to give the respect to the radiographers, right, you guys? This is a lot here. And we got to know this. But guess what? If other people can do it, you guys can too. All right? The group before you and the group before all of us have learned this math. If they can do it, you can do it. All right? It's just multiplying and dividing. But we got to know what to multiply and divide. Okay? All right, you guys, I'm going to stop right here, you guys. This is Fluoroscopic Math. When you guys come back, I'm going to write some things down about fluoro. And then we're going to talk about visual perception, visual acuity, and how to understand perception of our vision. All right? So trying to keep these under 30 minutes. We'll stop right here. We'll see you guys back in a little bit. Okay?